In this lesson, we're going to discuss how elements combine to form compounds. And in particular, we're going to look at a particular type of compound called an ionic compound. So, all of the compounds that exist on Earth are built from elements. There are 118 elements on the periodic table, but only 80 of them combine to form compounds. To give you an example of just how many there are well over 10 million known compounds and billions of possible sort of chemical combinations. Now, of the elements, carbon and hydrogen are known to combine in millions of different ways to make compounds with very different properties. So there are two different types of compounds we'll discuss. So ionic compounds uh, are compounds made of oppositely charged ions. And then covalent compounds are compounds that are made of atoms that join together to form molecules. We'll discuss those later. The way in which they form is quite different, and the properties that result of that formation are different as well. So in an ionic compound, the ions are held together with ionic bonds. There's a very strong attraction between oppositely charged ions. You might be familiar with the phrase opposites attract. So ionic bonds are, as I mentioned, very strong. So to understand the formation of ionic compounds, we're going to look at a type of ionic compound called a binary ionic compound. So you're maybe familiar with binary code, right? Binary means two. So if you see the word binary, think of the number two. In the case of binary ionic compounds, they're made of two different elements, a metal and a non-metal. And they form when atoms of the metal element each lose one or more electrons to atoms of the non-metal element. So metals lose electrons, non-metals gain electrons. And the formation of ionic bonds results in the formation of ions that have full valence shells. And it is this concept of a full valence shell that drives the formation of compounds. You might remember that noble gases are the chemical family that are very, very stable. They are stable because they have full valence shells. Now, we'll look at an example of an ionic compound. And a well-known example is sodium chloride, or table salt. And to understand how this compound forms, kind of a fascinating process. And when you look at sodium metal, for example, sodium metal is a very, very hazardous element. So if you drop a chunk of sodium in water, for example, it will explode. It's not something you would want to put in your mouth. Okay? It reacts very readily with chlorine gas. So chlorine gas, if you may remember, belongs to the halogen family, and these elements are all very reactive because they only need one electron to fill their outer shell. Now, what fascinates me, when you put these two elements together, and I described how they're hazardous in different ways, you get a compound that is a critical part of our diet. So we do need a little bit of sodium in our diet, and we usually get it from its ion form. And so it's really interesting for me to talk about chemistry in this way, how it can result in compounds with drastically different properties from their component elements. Now, sodium chloride forms when sodium atoms each transfer one electron to chlorine atoms. So each sodium atom becomes a positive ion. So we represent that with the element symbol and the positive charge written as a superscript. Okay? And each chlorine atom becomes a negative ion. So this diagram here can illustrate it for you. Here you can see the one extra electron here that sodium has, and you can see the space here that chlorine atom has that it needs one. So what happens in the formation of sodium chloride is sodium metal reacts with chlorine gas, and the atoms, in the case of sodium, give up their extra electron to chlorine atoms that need it. And then we can now see here that a sodium ion has resulted. You'll notice that that extra electron is missing, right? And you notice here that the chlorine atom, its outer shell is now full. So both of these in their ionic form are stable, and the opposite charges here hold the ions together. So now that we've talked about how these compounds form, let's talk a little bit more about their properties. So first we need to understand the structure. So sodium chloride results from sodium ions and chlorine ions repeating in a pattern here. Okay, so the positively charged sodium ions, negatively charged chlorine ions occur in a repeating pattern, and it results in this very cubic lattice structure here. So the other thing that results from these very strong bonds are three very important properties. So number one would be the high melting points. The second one we'll discuss is the hardness of these ionic compounds, and the third one we'll discuss is conductivity. So to understand the high melting point, we mentioned how these strong forces hold the ions together in that lattice structure. It requires a very large amount of energy to break those ionic bonds. So if you add heat to, say, a big sample of sodium chloride, you can eventually get it to melt, but it is a very high temperature. You see it there, 801 degrees Celsius to melt sodium chloride into liquid sodium chloride. The second key feature of ionic compounds is that they're hard and brittle. So you can see from the first diagram up here is that the the charges occur at regular repeating intervals, and a positive charge is always balanced with a negative charge. Now, you can um, break apart this lattice structure, but it requires a tremendous amount of force in which you would then realign the particles here. And you can see with this example, okay, or with the little highlighter, but you can see that if you apply enough force, you can eventually realign those particles so that like charges are beside each other. And when you do that, they will now then have a repulsive force to help push it apart. So that leads us to our final property, and that is discussing conductivity. So ionic compounds will conduct electricity when they are dissolved in a liquid, when in liquid form or when they are dissolved. And the reason they don't conduct in solid form is because these ions are held firmly in place. In a liquid form, so in dissolved or in liquid form, you can see all the space there so that these electrons have room to basically, or these charges have room to flow about. Okay, so that's why ionic compounds conduct electric current. So I hope you understand a little bit more about ionic compounds and how they form. And stay tuned for another lesson on covalent compounds to come.